Pre-Calc BC, section 9.2, page 5. Today we are looking at polar graphs and their intersections. And this is not in your textbook, but it is an important concept, especially for BC calculus next year, so we need to go over it. We're going to start by, we're looking for points of intersection between two polar equations. So we have this one, r equals 2 plus 4 cosine theta, and this one, r equals 3. When you're finding points of intersection, you're finding ordered pairs. And instead of finding ordered pairs, x, y, you'll be finding ordered pairs, r, theta. So we look at this first one, r equals 2 plus 4 cosine theta, and r equals 3. Since both equations are equal to r, we can set them equal to each other. And we have 3 equals 2 plus 4 cosine theta. Solving like normal, let's subtract this 2. Oops, 3 minus 2 is 1, is 4 cosine theta. And divide out the 4. Cosine theta is 1/4. Taking the inverse of both sides, we will have that theta is inverse cosine of 1/4. And when we solve these, we are going to solve them just for one time around. And this time, we are going to solve for theta between 0 and 360 degrees. So, cosine equal to 1/4, not a memorized place on the unit circle. So go ahead and grab your calculator. And make sure your calculator is set in degrees. Let me turn my contrast down here so you can see this. Yeah. Set in degrees. And let's go inverse cosine of 1/4. And we get 75.522. Those are degrees. Now keep in mind your calculator is restricted and giving answers just in the domain of first and second quadrants for inverse cosine. So we do need to think 75.5 degrees right about here. And the same spot, where else on this circle is cosine going to be also 1/4? And that would be down here at negative 75.522. But that negative 75.522 is not within the domain 0 to 360. So we're going to have to add 360 to this. So I'm going to do 360 minus that answer. And that will give us 284.477. Okay, then remember our answer here is a set of ordered pairs. Well, these are the angles that show up, and we already know that r is 3. So setting up our answer, r 3, 75.522 degrees, also 3, 284.477 degrees. That is your final answer. Looking at this next problem, r equals 4 sine squared 2 theta and r equals 3. Again, we'll set these equal to each other. 3 equals 4 sine squared 2 theta. Divide out the 4. Square root both sides. Don't forget that plus or minus. Square root 3/2. All right, now again, remember from last chapter, since we're going multiple times, or we just want set time between 0 and 360, then this is the time that we want to just loop around the circle and not use the K idea. So solving for 2 theta, sine to be positive or negative square root 3/2 would have to be up here at 60 degrees, 120, 240, there's the negative sign, negative square root 3 over 2, and then also 300. But then, since theta is between 0 and 360, 2 theta is between 0 and 720, which means we need to go a second time around the circle. I'm just going to start listing these off. 2 theta then was the first one. 60, 120, 240, 300, and then this 60 plus 360, which is 420, and then 120 plus 360, 480, and then this one 240 plus 360, 600, and then the last one 300 plus 360 is 660, that's funny, 660. All right, those are all answers for 2 theta, so we'll need to divide all of these by 2, which means that theta is 30, or 60, or 120, or 150, or 210, or 240, or 300, or 330. There's theta, but we are not done. Your answer here then is ordered pairs, and the ordered pairs are all 3 comma each of these degree values. So there are 1, 2, 3, 4, 5, 6, 7, 8 points of intersection. So if we list them all, 3 30 degrees, 3 60 degrees, 3 120, 3 150, 3 210, 3 comma 240, 3 comma 300, and 3 comma 330. Whew. So your final answer here is those 8 points of intersection. All right, now for this last one, you do need to go onto your calculator. There's something that you need to understand about polar graphing and points of intersection, so this is a really important thing. If you did not get your calculator out for the last number 9, shame on you. Pause the video right now and grab your calculator. You're gonna need it. I just want to make sure that you can see this. I'm going to show you some things about your calculator that you may or may not be aware of. All right, so first thing, we want to be in degrees. So make sure your mode is in degrees. And your window then, instead of going 0 to 2 pi, please set your window to be 0 to 360 for theta. And let's go with a theta step of every 5. So the calculator will generate points every 5 degrees. X values, please set them -6 to 6. Y values, -4 to 4. If I'm going too fast for you to set this on your own, pause the video until you catch up. Then let's go to Y equals. And I've put one equation in here, R equals 2 sine 2 theta. And the other one is 3 cosine 2 theta. I have these concentric circles in here, but I have them turned off. Usually I only use those concentric circles when I'm going to be transferring onto graph paper. If you have a color calculator, please make sure that these R1 and R2 are different colors so you can differentiate between them. If you do not have a color calculator, then go over here and you're just going to have to enter through until you get a thicker line on there. And I believe it's just one click there to get that to be a thicker line so you can differentiate between the two. Once you have that, then we go ahead and graph. Oops, mine's already done for you, but go ahead and do yours. And let's count the points of intersection here. Center, there's 1. And then right here I got 2, 3, 4, 5, 6, 7, 8, 9. Oh my goodness, it looks like there's 9 points of intersection. Now, maybe you caught that when I said it looks like. There really are not 9 points of intersection. So what I'd like you to do, go to your calculator, go to the mode, and I want you to look down here in this first column, and you probably have sequential as highlighted. And sequential means that your calculator will graph each function individually, one right after the other one, so in sequence. I want you to graph these simultaneously. So put that on simultaneous, which means it will graph the two equations at the same time. Oops. Okay, you see the two of them graph at the same time? That went pretty fast though, so I do want to change something here. Instead of one going right after the other one, it graphed them at the same time. Go back to your window, and I want to slow this down quite a bit because it's graphing too fast. So change your theta step here to, say, 1. And that should be slow enough for us. And all right, now let's graph. Okay, I have paused the graphing because I hit enter on my calculator and it pauses the graph. You can see that you've paused because can you see this kind of cursor up here? This, you can't see it in the video, but on yours, it should be kind of spinning around. It's not picking up very well in the video. But that means that this program, this graphing idea is paused. If I hit on, it stops the graphing. Enter pauses the graphing and then lets you pick up. So right there we see 1 point of intersection. And we're looking for the blue and the red on mine to cross. All right, there was a second point of intersection right there. They crossed each other at the same time. Right there is another point of intersection, so there's the third one. All right, now I'm going to stop here for a minute. My red one is in the process of going up this way. See how it looks like it's going to cross that blue one, but it's not hitting, it's not graphing that point right there at the same time that the blue one graphs. So that point right up here is not really a point of intersection. They have to hit the same R value and same theta at the same time, and that point is not. They're hitting it at different times. That's a point of intersection because those 2 points are being plotted at the same time with the same ordered pair, same coordinates. I just stopped it again because again, this red one passed through the blue, but the blue was in the process of graphing over here where it passed through another branch of the red one. So that one is not a point of intersection up here, and this one is not a point of intersection down there. And we finish up the graphing. So if we had gone through and counted, there are really only 4 points of intersection. There are only 4 points of intersection. So the other thing I want to point out to you is, you know how when we're in function graphing, to find points of intersection, you can go to the second calc menu and do intersect. When we're in polar, if you go second calc menu, there is no points of intersection. You can't find intersect here. You can't find 0 here. We just have value, and then these two items, dy dx and dr over d theta, those are calculus topics, so you'll understand those more next year. All right, so again, we're out of intersect, so we're going to have to go back and solve this by hand then. It's very similar to the last one in that both equations are set equal to r, so I can set these two equal to each other, and we will have 2 sine 2 theta equals 3 cosine 2 theta. All right, now you may not see what to do right away, but just bear with me. Could I divide both sides by cosine 2 theta? That would give me 2 sine 2 theta over cosine 2 theta equals 3. Then divide out that 2, this 2, not the 2 that's inside the sine, but this 2. And we're going to have sine 2 theta over cosine 2 theta, which is equal to 3 halves. Hey, what's sine 2 theta over cosine 2 theta? That's tangent 2 theta is 3 halves. So we can find this now because we want to know where tangent of 2 theta is equal to 1.5. And we are limited here for 0 to 360. So because it's a coefficient of 2, we're going to go around this circle twice. Let's find our answers for 2 theta. And let's go inverse tangent of 1.5 and 56.309. So one of them is 56.309. Okay. Also going to be, where else is tangent going to be equal to 1.5? It's going to be straight across the circle from there. So that's adding 180. So 236.309. And then this one again, plus 360. But that's just 180 from here. So 236.309 plus 180. And I'm going to have to add 180 to get the next one. I might as well do that right now. So we have 236.309, then a 416.309, and a 596.309. All right, those are answers for 2 theta. So we're going to have to divide each of those by 2. If you recognize that way back in the beginning, as soon as you generated that 56.309, you could have divided it by 2. And 56.309 divided by 2 is 28.154. Okay, 236.309. Divide that by 2, 118.154. Okay, are you noticing some patterns here? All these decimals up there were 0.309. When we divide by 2, all of them are going to come out to be this 0.154. To get this beginning to 56 divided by 2 was the 28. 236 divided by 2, 118. 416 divided by 2, 208, and then 0.154. 596 divided by 2, 298.154. Okay, now that's just the thetas. We need to find the ordered pairs. On these last two, it was very nice to find that r value because that was one of my equations, r equals 3. The other equations down here, I don't have an r equals 3, so we need to remember back to previous math classes where once you found the value of one variable, then you just went ahead and substituted that answer into one of the two original equations to find that particular r value. So let's do that. We're going to have to take this 28.154, whatever it is, and we're going to have to substitute it right into here, either one of those equations, 2 sine 2 theta. So I'm going to go back up here to grab this. Well, let me put this in first. 2 sine 2 times, and I'm going to take that 28.154, this one, put that in there, divide that. Whoops, I don't have to divide that by anything. Delete. Yep, 2 sine 2 theta, done. And that is 1.664. So this first one, 28.154. Oops, ordered pairs are not theta comma r, they are r comma theta. Okay, that's just not working crazy white out. There we go. So r 1.664, comma, 28.154 degrees. That's one of them. Let's find the next one. So I am just going to go back to sine 2, and then it was that 118.154, and that's, uh-oh, I have an extra 2 in there. Do you, oh, because I forgot my times in here. I'm going to go back and insert a times. 2 times 118. There we go, negative 1.664. So 118.154 degrees gives us negative 1.664. And let's see, the next one with a 208.154 to sine 2 times that 208.154. Well, that's also just that 416.309. If you want to go back up here and grab it, there it is. So I already did the times 2, kind of. Well, not kind of, definitely. So that's 1.664. And when you substitute this last one in at 298.154, you will get a negative R value, negative 1.664. And there we go, your final answer for this problem. There. Nice. Thank you very much. There is a worksheet to go along with this assignment. 7th hour, Mrs. Bonner will give you that worksheet, and 8th hour, Mrs. Walker will give you that worksheet. Have a good day. See you tomorrow.